Anyway, let's return to our fictional space um, vehicle, and um, you can see that you already knew about the state struct. We've seen that in the tests. The
Yes, so
game,
this is our new game function, yeah.
yeah, the game struct currently doesn't contain anything other than the state vector, let's call it, because that's what it really is.
Hmm.
Um, but it could, and we had a discussion about this earlier on about, when you represent the state of what? What is the right thing to represent the state of? Should it be the entire world, or should we just think about the lander? Because you can imagine a game where, you got more than one player, more than one vehicle. You might be able to shoot each other, for example, like the old Space War game.
Or
Or
playing game on the different planets, right? And
yeah,
then we need to deal with the gravity that changes.
yeah, exactly. So what we thought was there is a state vector representing the lander,
Mhm.
and the game needs to know that. But there could be other state vectors, so we've left room for them. They could go in the game, couldn't they? You could have lander state is a state vector, and attack ship state. You know, maybe you're
Yeah.
you're sort of being attacked by space pirates as you're trying to land. Um,
Or storm is approaching, right? For
yeah,
example, yeah. And some additional the objects from the game, right, that we could introduce in the future.
exactly. So while most people watching this, the Go programs that they're writing, if any, are probably not about space. Nonetheless, they're facing the same kind of decisions, aren't they? Like when there are, how should we say it? There are often several reasonable alternative ways to structure something or to lay out some data type, and it's not, one isn't obviously better than another, is it?
Mhm.
And I think sometimes people can be kind of paralyzed by that and just think, well, I don't know which to choose. And I guess my answer would be, well, just pick one, you know, see how it pans out. It's probably the wrong one. That's okay. You know, we're we're sort of comfortable with constantly chopping and changing our code, aren't we? Or at least I am. I'm getting more comfortable with that.
And just avoid analysis paralysis, like they named this.
Yeah, that's right. And I have worked with people, or like when I've been training them, people are very experienced engineers in other languages. They want a conversion course to go. Um, I find, that they're curiously reluctant to touch anything. It's like if they have some code, it's almost holy. We mustn't change that. Um, or they're very nervous about changing it. And I think that's probably because, if you're from a world where you don't have great test coverage or any
Mhm.
tests, and the code isn't easy to read, and it's just, you know, so what you have is a bunch of code you don't understand, and it probably works now, more or less, but any change you make to it is much more likely to make it work less well. So, and they've no way of detecting that. So they're just living in a state of fear all the time, which is terrible. And I remember that because I've been in that situation, and I think part of me falling in love with tests and especially test driven development was this idea that basically it eliminates fear, isn't it?
Yes, any changes, you can always run tests and figure out if your change actually breaks something or not.
Yeah, exactly. And
Yeah.
if I'm suppose I see some change that I could make and I think I'll just make it, I'll run the tests, okay, everything passes, so it's fine. Maybe it's not really fine though. Maybe I just introduced some subtle bug which isn't covered by tests, and that would be bad, but I'll take that risk. I'm all right with that because really that's just telling me I'm missing some tests, isn't it? Well, that's great. you know, if I when I find that bug eventually, um, I'll know what test to add, won't I? I'll add the test that would have caught that problem straight away. And we do that all the time, don't we? We we find bugs in programs. Um, Bugs do happen, and what we do is we add a test which demonstrates that bug, and then we fix the bug, and then the test tells us that we're done, and then we just improved our tests, which is fine. And I think it's just a very different mindset where, you feel safe to make changes. So just working on a code base becomes easier, doesn't it? Because 90% of the work we ever do on code is maintaining existing code, isn't it? Not starting new projects.
Yes, yeah. So there's a lack of this fear that some, for example, change would break the build or break code. It's really revealing. So it's nice to have this safety net. And
Yeah, exactly.
even if we want to, let's say, refactor the Go code in terms of, let's say, putting the different packages, because I remember a couple of situations that people were spending literally days at the very beginning of the project figuring out what's the structure of the repository should look like. That we can actually, having tests, we can refactor this at any time and discover packages.
Yeah. So many arguments about project structure. And you're absolutely right that I think that's a good example of what we're talking about, that it's something where there are lots of reasonable alternatives. It's not clear right now whether one's better than another, but it will become clear later. So just roll with it, and because you feel safe doing big refactorings, you just can. And what I suggest to people is that they should just let the project itself tell you what its structure should be. As you're writing the code, you will find yourself thinking, this really doesn't make sense that I have to import this other package and call it. So fine, change that, and the structure will hopefully evolve towards something which is sort of nice. If not, it's possible to refactor it that way. So it just saves a lot of bike shed arguments, doesn't it?
Exactly.
Which is great, because as fun as that is, to spend a week arguing about what the name of some folder should be, it's also nice to actually get on and ship stuff. So new game we knew would be very simple, because we saw the struct literal that it returns, and that's all it does, is it just returns that. There could be some configuration, of course, difficulty settings or whatever, but we don't have that yet.
So the point to notice is as well that every time we create a new game, for example, in the situation that if you would like to play 2 or 3 games, we are returning the copy of the game struct, right? So we are not dealing with pointers here.
Indeed. Now there are some pointer methods on game for obvious reasons, like, we need to be able to modify the state of the game, or it wouldn't be very fun. If all you can do is watch the ship crash, that's be a bit sad. So display state is a value method. That makes sense because it's just displaying.
Yeah, here line 27.
Yeah, and as we knew, it would take some IO writer, which it does. That will be os.stodout in the real game, presumably.
And this is a really nice approach I see here, because by using actually IO writer, we can already think that this method, for example, could be easier later on to adjust, let's say, if we want to create some web interface.
Yeah, absolutely. And even more generally, if we added graphics, then presumably we would be using some GUI library where we have some window, some ability to draw pixels. Yeah. We wouldn't pass in IO writer, but the idea is sound that we would basically say, here's the thing to display yourself to. Via perhaps some interface. I don't know. Never really done any graphics programming, which is another massive gap in my experience. So I wonder if that's actually how things do work. But this is very straightforward, isn't it? Just fumped, nothing fancy yet. And the same with read thrust, actually.
Yeah, so read thrust with the difference only that we have here the pointer to the game. Okay, and we have read thrust. Okay, we have IO reader, IO writer, input, output. So as well, we are not limited to particular type.
Right. And because we take a pointer to the game, that sends a strong message that we are going to modify that game, doesn't it?
Yeah, yeah.
I mean, we don't have to, but there'd be no need to take a pointer if we didn't. So that's sort of semantic. And this is another one which people can get very confused about in Go, isn't it? As pointers in general are a bit intimidating for people. Though once they're explained in the right way, people always say, "Oh, but that's so simple. Why does everyone make such a fuss about it?" you know, which is true of most things, I think.
Yeah, so that's the key to properly explain or have the different explanations, because different people have, for example, some people have the memories for when they see something and they need to create a model in their head.
Yeah.
How
Exactly. So if you struggle to understand something like pointers, it's not your fault. It's not that you're dumb. It's just that somebody hasn't found the right form of words that makes sense to your brain to explain it.
Mm-hmm.
Not the same words don't work with everybody, but once you do find the right way to frame it, all of a sudden it becomes very simple, which is great. And then the next point of confusion is likely to be, well, then when should I use a pointer or when not? And because the purpose of pointers is precisely to confer the ability to modify the thing, that sort of answers it, doesn't it? It says if you need to modify the thing, then you should take a pointer, because you won't be able to otherwise. And when you're reading code, if you see a pointer coming in, you're like, I think that thing is going to be modified. And indeed it is. You can see at line 33.
Yeah. Here. So
Reset the thrust. So that makes complete sense, I think.
Yeah. So we are getting input as IO reader, whatever later on struct we will put here, whatever object that implements the read method, we will be okay here.
That's right.
And then the next one that we have update world. So this is this method that we tested, and we're talking about the updating state of our game.
Yep. So here comes the science bit.
Yeah. Okay. So basically we are altitude. Okay. Changing to velocity, then velocity, gravity.
Yeah. So basically, three things happen, isn't it? Our altitude is going to change based on how fast we're moving up or down. That's very straightforward. Happens on Earth too. Our velocity is also going to change because we're being accelerated by gravity. And it's also going to change because we're being accelerated by the rocket. That's what it's for, isn't it? Gravity is pulling us one way, the thrust is pushing us the other, and hopefully between the balance of those two forces, we'll achieve a soft landing. But really, those are the only things that happen in our physical model. More things could happen. You can imagine, for example, if we had fuel, then this would be where we update the fuel, wouldn't it? We would say, how much fuel are you burning per game tick? Well, decrement it by that amount.
Yeah. That would be perfect place for fuel.
Yeah, probably just a function of the thrust, isn't it? So, and this is another thing that, right now, this is sort of what you might call a turn-based game. It's not a high-octane real-time game where, you have to stay glued to the keyboard. It's it just prints a prompt and waits for you to type in, and the stimulation is frozen until you enter something. So you can get up and make yourself a cup of tea, which is nice. It'd be good if real space missions were this relaxed. But in order to make a more exciting game, one thing that we could do is make it effectively real time, isn't it?
Yeah.
how would that change things? I mean, it doesn't change the fundamental architecture of the game too much, does it? Because instead of just waiting in read thrust, we could just sort of say, obviously you wouldn't have time to type, but you could imagine keys for sort of thrust up, thrust down, couldn't you? Or even a joystick or something. And I think you would just you'd just sample that, wouldn't you? You'd say, is the player pressing a key at the moment? If not, well, they've missed their chance for this frame. We'll come back and check again later, but they're plummeting towards the moon until they press something.
And every action will actually trigger the update word, could trigger update word, the method, right?
Yes, exactly. And if in effect, we'll still have the same game tick structure, but the ticks will just happen at fixed wall clock times. I think Doom, for example, had a fixed 30 hertz tick rate, which was all they could do, on a 286 or whatever. And if you play a port of Doom on a modern computer, of course you're getting more frames per second from the GPU. You're getting 60 FPS per eye in VR or whatever, but the game itself still only updates its world 30 times a second. If you're moving, you will not move continuously, but you'll just sort of make tiny jumps from one point to the next, and those will happen 30 times a second. And we could do the same here, couldn't we? We probably don't need that high of a refresh rate, do we?
Yeah.
Maybe just, because it's, effectively, what does the player see? They just see this printout. How many times a second are we going to print out that state vector? Not that many, right? It would just be impossible to read.
Once a second would be be enough, I would say, every second.
Yeah, the screen would be scrolling like crazy, and that raises another point, doesn't it? That it would be nice to actually sort of address the terminal to just update that information rather than constantly printing new lines and scrolling. The original game just scrolled. But we can do better. We could use ANSI escape sequences, couldn't we, to sort of rewrite the current terminal line.
Yeah.
That's fun to think about. So, I think that this concludes our sort of picking up the threads of the game, doesn't it? Oh, we should look at the CLI, though.
Well, let's have a look in the CMD folder. Let's open the main.
Yeah, and we think this should be fairly minimal. It's not as minimal as I'd like it to be, but what we started out doing, of course, since you know how I work, is I use main-driven development. So I try and write a whole working program just in main, not worrying about structure in the slightest, because I don't know what I need to structure yet until I've written the program. So I write it, and then I say I think I could move most of this into some package. Lambda, let's say, and now I can start to break up this big mush of code into functions like new game, display state. I know I'm going to have some loop, but what I really want is my main to be just something like import lambda.play game, isn't it?
One simple short the main, and then the business logic of the game keeps separately.
Yeah, exactly, because any logic that's in main is not importable by anyone, So as you said, if somebody wanted to make a web-based version of this, they would have the new game function, they would have the read thrust and display state and so forth methods, but they would have to write this loop themselves, and they would also have to calculate the landing themselves. And that's just nuts, because that's clearly part of the game, isn't it? So that should be in the Lambda package. So, this is up to you whether you want to work on this now, as we could try to move some more of this into the Lambda package and reduce main to basically just run game. Or we could add further features as is, or refactor. Choose your own adventure.